welcome to our channel. Today let's begin with the topic speed, which is another physical quantity that is used to describe any motion. By definition, speed is rate of motion, that is how fast an object moves. Or we can say that speed is used to find out the distance traveled by any object in unit time. So that gives the formula for speed. Speed, which is denoted by V, is equal to distance covered by time. That is, it is a distance covered by an object in that particular time period. Here distance is denoted by S, whereas time is denoted by T. V is equal to S by T gives the formula for speed. SI unit for speed is meter per second, but we may also use kilometer per hour or centimeter per second to denote speed. Now, in most of the cases, speed might not be a constant value. That is, in most of the real life examples, the motion might be a non-uniform motion. Okay, so before we proceed, we need to know what is meant by uniform motion and non-uniform motion. The name itself suggests, right, what is uniform motion and non-uniform motion? Uniform motion is when the object covers equal distance in equal interval of time. Equal distance in equal interval of time. So what would be non-uniform motion? That is when an object does not cover equal distance in equal interval of time, right? Yeah. So in such a case, so when the motion is non-uniform, the speed might not be constant, right? In such cases, that is in the cases of non-uniform motion, we use average speed. Now what is average speed? Average speed is nothing but the total distance covered by the total time taken. V average, right? Okay, so let me explain this with an example. Suppose a car travels 100 kilometers in 2 hours. So that means S is equal to 100 kilometers and time is equal to 2 hours. In this case, V average would be 100 by 2, that is 50 kilometer per hour. What does this mean? That means that the car had an average speed of 50 kilometer per hour. So the car might not have traveled 50 kilometer per hour all the time. Sometimes it must have traveled faster, sometimes slower. But we say that the average speed of the car was 50 kilometers per hour. Now that we have discussed what is speed, let's see what is meant by velocity. Velocity is also a speed, but it specifies the direction the object has traveled. That is, apart from specifying how fast the object has moved, it also talks about the direction that the object has taken. That means velocity has both direction and a magnitude, or we can say that velocity is a vector quantity. Velocity is a vector quantity, whereas speed is a scalar quantity. I hope you guys remember what is meant by vector and scalar quantities. Vector quantities means it has both direction and magnitude, whereas scalar quantities have only magnitude, that is, it contains only the numerical number. Now, velocity is the speed of an object moving in a definite direction. That means if the object is moving in only one single direction, then velocity will be equal to the speed of the object. The formula for velocity is given by displacement by time. Velocity is also represented by v. And the unit for velocity is same as unit for speed, that is meter per second, kilometer per hour or centimeter per second, but meter per second is the SI unit. Let me explain the difference between velocity and speed with the help of a simple example. Consider an object that is moving in a rectangular path. That is, the object will start its journey from point A. Let me name the corners as A, B, C, D. That is, the object will start its journey from A and it is moving with uniform or constant speed. That is, the object is moving with constant speed. Now, as the object starts its journey and it is moving with constant speed, it reaches this point B. Now, at this point B, the object has to change its direction and move towards C, right? In that case, even when the object is turning, it is not changing its speed. The speed is constant, but it changes its direction. So I can say that the object has changed its velocity. Now, after reaching point C, it again changes its direction. So we say that the object has changed its velocity but not the speed. The speed was constant here, but the direction has changed, thus the velocity has changed. Similarly, even at point D, the object has to change its velocity. Now in this case, I can say that the velocity or the object has changed its velocity 4 times. That is, one at this point, second point, third point and fourth point, without changing its speed. So this is the major difference between velocity and speed. Now there is one more important physical quantity that we need to discuss in this chapter: acceleration. Acceleration tells us how much velocity changes in unit time, or it is the rate of change of velocity. Let me explain this with an example. Consider a uniform motion and the object is moving along a straight line. Now, since the motion is uniform, its velocity will be the same, right? Its velocity will be the same throughout the motion. In this case, change in velocity will be 0 because the velocity is the same all the time. The value for velocity is same. But now, consider a non-uniform motion. In this case, velocity will change, right? At different instants, the object will have different velocities. So here, change in velocity is not 0. That is because since the velocity is not same all the time, there is always a change in velocity. So let's take any time interval t. any time interval t. So during that time interval, the object will have a initial velocity, that is u, represented by u, and a final velocity, that is represented by v, right? You get the point? During any time interval, that object will have an initial velocity and a final velocity. Why? Because the velocity is changing, right? So at that instant, the object will have an initial velocity, and when that instant is ending, it will have another velocity. So those two velocities, initial and final velocity. In this case, acceleration will be given by final velocity minus initial velocity by time. So this will be the formula for acceleration. Change in velocity divided by time taken. The unit for acceleration is meter per second square. So now we know that acceleration is equal to final velocity minus initial velocity by t, that is v minus u by t. Whenever there is a velocity change, there will be an acceleration. This is what we have studied so far. Now consider these two cases wherein, so the first scenario, okay, take an example of a car. Alright, so this car was moving at a velocity of 50 meters per second. So initially the car was moving with a velocity of 50 meters per second, and after some time, that is 10 seconds, we found that the velocity of the car has changed or increased to 75 meters per second. So what happened? The car was initially traveling with a speed of 50 meters per second, and then after 10 seconds we found that its velocity is 75 meters per second. So 50 meters per second becomes the initial velocity u, and 75 meters per second becomes the final velocity v. In this case, acceleration of the car will be given by this equation, that is a is equal to v minus u by t, that is final velocity is 75 minus initial velocity is 50 by time is 10, t is equal to 10 seconds. Here the answer will be 15 by 10, that is 1.5 meters per second square. Alright. Now consider one more case. Let us take an example of a bus. Okay. Now this bus was traveling with a speed of 80 meters per second, and then it decreases its speed to 60 meters per second in 5 seconds. Okay, that means the initial velocity of the bus was 80 meters per second, and in this 5 seconds its velocity decreased to 60 meters per second. In this case, when we find acceleration, it is also final velocity minus initial velocity by time. Here final velocity is 60, because after this time interval the velocity was 60. So the 60 is the final velocity. 60 minus 80 by 5. Here 60 minus 80 will be negative 20 by 5. So the answer is negative 4 meters per second square. That means acceleration of the bus is given as negative 4 meters per second square, and the acceleration of the car in the first case was 1.5 meters per second square. Alright. So why there is a change in sign for the acceleration in the first scenario and in this second scenario? What has happened? In this first case, the car was initially at initially at 50 meters per second, and then it increased its speed to 75 meters per second. That means the car accelerated, right? The driver must have given accelerator. But in the case of the bus, the driver was initially or the bus was initially at 80 meters per second, and then the bus decreased its speed to 60 meters per second. Here the driver must have given the brake, that is the bus decelerated here. So deceleration happened. So we had final velocity a smaller number than the initial velocity. Thus we got acceleration as a negative number. So what happened? In the case of the bus, or in the case of deceleration, we will have negative acceleration, whereas in the case of acceleration, that is increase in speed, we will be having a positive acceleration. I hope you guys got the concept of negative acceleration and positive acceleration. Now in the next video, we shall do few problems related to this topic.